it's humbling for me to be in this space. Before Workday, I was 6 years working in AWS on the active monitoring side on the network. And before that, I was on the Brazilian army as a sergeant. So if you want to talk about electronic stuffs and electronic war, cryptography, this kind of stuff, we can discuss some things. Before that, I was working in the Brazilian government for electoral systems. If you want to know about electronic elections, like how we get the president in 40 minutes, we know what's our president, if that's safe or not. Yeah, it's more costly than safe, actually. And before that, I was selling popsicles on the streets to buy books, to study, to be in Brazilian army. So that's why it's humbling for me to be here, and thank you for having me. My name is Leonardo, but like you can call me Leo, or if you want to be very correct, it's Leo in Portuguese, Brazilian Portuguese. I'm from Brazil, living in Dublin for the last 7 years since I joined AWS there. And so we have an agenda for today, a very basic one: who, why, what, where, this kind of stuff. So we are going to break down this problem, how we scaled, like all the problems we faced while scaling Elastic. I think everyone which works with Elastic has quite similar problems and knows the limitations on scaling and how, and when you go to scale of petabytes, it starts to get more and more complicated. And why did we decide to go to this approach? And I'll explain the details of this approach as much as I can. And the outcomes at the end, some Q&A. Let's see how it goes. So who we are, I'm part of the observability team at Workday for the last 1.5 years. This project happened in like 6 months, last 6 months, 1 year. Observability is responsible for metrics, logs for the whole company, differently from AWS or many big companies that small teams take care of their logs or just onboarding system that will bring your logs. Like in Workday, we have this big system that serves the whole company and all the customers to about our logs and our metrics and everything. So yeah, and I need to recognize our heroes, like the guys that were pushing me to, hey, we need to do that because we are having a lot of pain and a lot of problems during our calls and how to keep scaling that. So Mark was 20 years in IBM before Workday. It was the guy that came to me with this term, like cattle versus pet. I was doing that in AWS, very cattle architecture for everything. I was doing pets on Brazilian government data centers before, but I was not putting both in the same place and thinking that we had to change our architecture in Workday from pet to cattle. I'll explain more in details after. And Valerio is a guy that was on the ground doing, since the beginning, Workday scale from Elasticsearch. He knows more than anyone else I know, everything about Elastic. And Aderval is the hero manager that was saying, hey, go for it. I brought the design, and like we should change these things like that. And it's always hard to get the buy-in from people, and I need to recognize that. He was like, go for it, try it, through a door. If it doesn't work, we try something else. So why are the aggregated logs so important for Workday? So as an ERP company, we have like human capital management, financial management, business planning. It's an HR, payroll, talent management, workforce planning. Like if we stop, like many companies in the globe will stop. So we will not receive your salary or some, I don't know, medical staff will just stop working because of our system. So we have very strict SLAs and SLOs, SLAs for our customers, internal SLOs. We need to respond very quickly if our log system is not good. Our support teams cannot bring the systems back as all the, like this big system full of models, all depends on the logs to identify our issues. So we have tens of petabytes and trillions of unstructured index logs per month. We store close to that. in terms of time, because cost and because of the importance of the log. Like 6 months log is not interesting for us. Like we are interested in solving problems that are happening right now or in the last 2 weeks, for example. And that's scary because we on average grow 5% every month. So approximately every 1.5 years we are doubling in size. So it's scary because either we are able to scale Elastic forever, or we need to change from Elastic to something else that can scale forever. And yeah, let's talk about how this thing started, the origin of this scaling problem. Like everyone else, we start with a POC or a minimum viable product, and you create like your small machine, you put like the data, like, let's go a step back first. Like everyone starts put a syslog. We start to drop syslog via UDP to some server. At least it's how I was doing that on the past. And you do pipe grabs and you find everything is fine. Your company is small. You don't need Elasticsearch until you find that Elasticsearch, I was there in 2010, 2012, when they start with Elasticsearch, and whoa, that's nice. I can create dashboards. I don't need to do pipe grab, all of this stuff anymore. I just send to Elasticsearch. I get my logs there, and that's nice. It's easy to convince people to move to that. But then your system starts to grow, like 2x, 4x, 8x, and you need to scale, you need to build a proper cluster, a proper design after you sell your MVP. And you think that, hey, vertical scale is okay. I think I just need to like put bigger machines. I have this 30 machine, that's okay, but until it's not. And you start to put more machines, like, okay, let's go horizontal. That should solve my problem. Everyone is talking about not vertical and going horizontal scaling. And you figured out that there is a limit. And if you see this master node on the screen is the elected guy to receive, like if you change a shard or any information that you need to share with your data nodes about your shards or about your indexes, is communicated to the master node. So the architecture of Elastic depends on this master node to keep growing. And if you have this intercommunication, too much intercommunication, you just will touch a limit there, and you cannot scale a cluster after a certain limit. Then you go there and you say, okay, I reached this limit inside my cluster. I have an idea. I just go to vertical scale again, right? Until the point that you don't have enough big machines on AWS, or your business guys will come to you, the financial team, and say, hey, stop that. You cannot scale like that anymore. Then you keep having awesome ideas, like, oh, by the way, this is a recommendation that you get from the support in general. Like, oh, don't go beyond 200 nodes with the default configurations, because that's not a good idea based on our internal information. But I found, like in Reddit and in talking to other teams from other companies, that there are people going to more than 700 nodes. The problem is, if you go more than 200 nodes, you start to tweak every single parameter, memory, and everything, and it's not to be great, and it's a very petty approach to your cluster. And how to keep scaling then? And you think like, okay, instead of having one cluster, I'm going to put 2 Elastic clusters, right? And I'm going to send part of my customers to one cluster and part of my customers to the other cluster. And also you think about, let's separate you have 2 problems, sorry. You need to separate the presentation layer and the data ingestion layer. How to tell my customers to search in this Elastic or Kibana screen or this other Kibana screen. How to keep ingesting at scale for these 2 guys. And the search path. First part of the problem. That part Elastic or OpenSearch, everything I'm talking here applies to OpenSearch as well. They are very good. They provide you this functionality that called cross-cluster search, that you can just configure that and say, hey, you go to one Elastic cluster, let's say your first one, your first path, and say, hey, you have the second cluster. When my customer comes here and do a search, you can just redirect the search to the second cluster, it will be transparent, and no one will notice that. You have 2 clusters behind the scenes, up to 200 nodes, and everything is great. But then you have a few problems there. Your first cluster handles, it becomes critical because it's a very big one. It has customer data, and it has presentation metadata like Kibana and alarms and dashboards and bunch of saved objects. If you lose this cluster or if something goes wrong, no one can access the second cluster. And you have a lot of heterogeneity issues there, like a lot of branches in code in your automation, like as SREs, you are working with a bunch of automating tools, templates, and you know how complicated it is if you have a lot of if-else to manage corner case. We didn't want that. And this is what your cluster looks like. So data from my first cluster, you have Kibana, you have everything there, but also you have alarms and everything. And data from cluster A are going to yes cluster, because you never thought you would have ES2. You thought you had just yes and that's it forever. You just put more nodes. But now you have ES2, you have ES3, and you have the brilliant idea of putting customer B in cluster B, customer C in cluster C, and you have a big of a problem. Like you need to go to every single customer and tell them where they need to write their data. So, and what about the ingestion path? We start to split in a lot of linear clusters. As we move from the data center to the cloud, because of time constraints, business needs, we just got all the paths we had on the data center, like, okay, let's solve that. We don't have more space and capacity on the data center, let's go to the cloud. We put the same thing on the cloud, and you just put like AWS load balancer in front of it, and some routing rules there, which was the same as not having a load balancer, because my customer could just write directly to a cluster. Load balancer was just putting some routing rules based on HTTP header or HTTP path. But now you need to, as I said before, inform every single ingestor. I'm abstracting, by the way, the layers before the ingestor. We have a lot of Kafka holding the logs and avoiding writing directly to Elastic. But like, I'm just abstracting that. And you need to configure every single ingestor to write to the right place. And that's a nightmare. If you think about tenants and customers that you need to go to their machine, we host that, but like, and change that on the fly when you need, as you scale your cluster. So it takes weeks to do that. And also these AWS load balancers, and I was there, they are not very customizable for you to say, hey, check not just the HTTP status code like 200, because sometimes my cluster is in yellow state, my cluster is in red state, and yellow, red, and all of these states will always respond to you with 200 state. Even if the cluster is bad, it will respond to you with like internally the information on your JSON or your YAML it's saying, hey, my cluster is bad, it's red, but the status will not be. It will just be 200, sorry. And of course, your first cluster is full of data. Your memory is high. Your CPU and your hardware profile is completely different from the second cluster and from the third cluster and so on and so forth. We have a lot of petty situations here. And yeah, same heterogeneity issues as in the search path, source-aware routing I talked about before, and no centralized strategy how to route your stuff to your cluster. We have traffic imbalances, hotspots, 90% of your data is in the first cluster, the second and third cluster, handling very few data. And you can't still, if one customer grows, like customer A grows forever, it can't grow forever this way, because you need to, hey, now I'm going to break down in customer A, or A1, A2, A3. It's a nightmare. And then adding new cluster causes naming convention issues, multiple deployment models. I need to deploy in one way in my first cluster, in a completely different way in cluster B, C, and D. And the operational load, imagine the amount of page we're getting with this model that we don't know if cluster is yellow, red, or green, and just keep ingesting to these clusters, and hard to change something without impacting my customer directly. And yeah, and of course, my customer will not stop coming every week, and it's not their fault, asking for new logs. I want to ingest new logs. I have a new use case. I want to keep growing, and we can't stop the company to keep growing. So we had a real urgency for a redesign. That's where Cato versus Pet start to come. And that's a very old term Mark came to me with. It was like 2016, Randy Bias introduced that term, like trying to illustrate the old way of doing things. Like we had, at least, I remember many years ago working in Brazilian government in a data center, and we had a server called Dexter. Do you know the Siri, Dexter? So we were putting series names, we were putting drink names, whiskey town, like things like that, Guinness, on the servers, because they are very petty. We knew the servers by name, like as a person. It was super interesting, and like if a server is down, a mail server is down, my CEO can't send an email because my mail server is down, or if a DB is down, or if a load balancer is down. It was very complicated to do a change. If you remember, like, oh, don't change things on Friday, this kind of stuff. And when I went to the AWS, it was a completely different approach, like because I was trying to change, when I identified the problem in my own call, I was trying to go very deep and trying to run perf tools and kernel stuff. I was doing that in my master's degree. And I was like, whoa, that's super interesting. I want to get to the bottom of this problem. And my Italian colleague come to me like, pronto, don't do that. You should just replace the server and don't care about it because we just keep monitoring these metrics. If you replace the server and the server is good, that's it. And we start to think about scale and about like servers needs to be replaceable, disposable. And that's the whole thing about this Cato versus Pet. The Cato approach is like, you don't have pets anymore. You don't put person names, drink names on the servers, but you just call that 01, 02, 03, or etc. And you can just drop any server at any time without impacting your customer. So we started to think about how to design this thing. And taking some of this AWS experience, it was like, we do that all the time there. Is like, oh, let's think about, it was how S3 started, for example. Let's think about the next 10 years. Let's design for the next 10 years. I don't know if I can achieve that, but let's put on the paper. After we figure out and put a bunch of smart people in the room and we discuss this design and see if that can happen. And the second was, we want to separate data from presentation layers. We want to support specialized cluster profile because many customers came to us saying, hey, my data is not that important. I want to put in your cluster, but my cluster is important. I can't put this data that's not that important. That's the best effort mode. But I wanted to put a best effort cluster there without impacting all the other clusters. I want to be cost effectiveness, have cost effectiveness because I didn't want to, let's say, put an expensive hardware. Like it couldn't be a requirement saying, hey, I need to get this specific AWS machine. I can work with any AWS EC2 instance to make that work. I want to work with any infrastructure as code. If I want to use Helm charts, Terraform, whatever, it doesn't matter. I want that design to work with that. Naming conventions needs to be standardized because you know the first problem in computer science is about names. We take more time discussing names than anything else. It, like S3 at the beginning of the design, it should be stupid simple. I can't complicate. You saw the professor talking yesterday about complexification, which should stop making very complex stuff unless it's really needed. And we wanted to think about self-healing. I want to know status like yellow, red, green, being part of my healthiness, the healthiness of my system. Then we put, as part of trying to achieve these requirements, a load balancer in front of everything that's not AWS load balancer, with able to outscale, like it's not a pet load balancer. I can lose any node of my load balancer, and it's still able to figure out stuff. We used AJ-procs for that because some familiarity and also the features were enough for what we had on the design, but it can be changed to any other load balancer. Redirects traffic to my group of clusters based on HTTP headers or paths. If I have specific profiles, I'll show that after. And not tag traffic, so I'm not going to lose traffic or impact customer. If they are not put in HTTP header or path, I just send to my default cluster. My default cluster of clusters, actually. I'll show what's that after. And we implemented TCP health check service with an idea from Brendan Gregg. I think everyone knows these guys nowadays from Netflix, which created this use method. I love that, and it just like based on utilization, saturation, and errors, represents the score of my whole subsystems, my cluster of clusters, and my subclusters. And I redirect traffic based on that. So if my cluster is bad, I don't send traffic to this cluster, and now I know that my cluster is bad based on that. And the formula is more or less like this, what we did. So basically I get like utilization, for example, based on CPU, it's the general parameter everyone knows for utilization, or memory as well. I didn't put that, but you can do as you want. We get the P90 because I don't want to get one bad server. Sometimes doesn't represent that my Elastic cluster is bad. It's just like one bad server and it auto-recovers. But I use P90 for that. Also after observations in real case disasters, issues, sorry. Thread pools as a saturation parameter there on the formula, and when a disk is getting full as well, it's close to get full, we don't send more ingestion to this cluster. Before, we were just getting paged because the disk was getting full, my cluster went red and went to read-only state, and my lag to ingest things was just getting insane. And with this B item in the formula, it's just like, no, if you don't have disks, one disk getting bad, I just alleviate the traffic to this cluster, and the other clusters can cope with the load. And more especially, Elastic knows better than anyone about the cluster status, and it can get you a red if the cluster is read-only, if you lose an index or if you don't have any shard for the specific index, or if you lose one AZ, for example, cluster goes yellow, or if everything is okay, cluster is green. So if you get red, we just zero this cluster score completely. Just multiply by 0, and that's it. Other than that, we use the yellow and green status to compose our score. If the score is low for all the clusters, we just keep distributing the load to all of them equally. But if one cluster is bad because someone was doing some maintenance and forgot some parameter in the code, it will not impact my customer. The cluster goes to read-only, and you are still able to search and to do whatever you want as a customer. So it started to bring like a transparent experience to the customer even when things are happening behind the scenes. So this is just a screenshot from in debug mode for this algorithm. We wrote that in a week in Python. It's just a replica set, a deployment running every single cluster, checking with Elastic what's the status all the time, and we opened a TCP port, made a TCP server responding with 0 to 100. And my load balancer, you see below, it's very simple, the configuration. Is just checking in the port 9600 what's the status every 5 seconds. We could even lower that, but like that's enough for our use case, that's logs. And that works really well. I'll show you some graphs later about what's the impact of that in practice. So other than the load balancer, we also put on this architecture management cluster. So instead of having this very petty cluster as the first one, we separated that. Like, I don't want to mess my data clusters with my management cluster. I'm going to put cross-cluster search and all the Elastic features, Keyban, et cetera, in this management cluster. And all my data is separated, like I'm abstracting this layer, and my customer is not accessing things directly anymore. We have now a single namespace. It's all in Kubernetes, but can be in anything else, with a minimal Elastic cluster there, acting as an entry point for search and ingestion through the load balancer and search through Kibana or APIs. We don't store any real customer data. And all the centralized tooling like LB, Kibana, cross-cluster search, all the metadata. And I show you also an auditor service we created as part of this. And yeah, as I mentioned before, this LB layer that has used this weighted round-robin method is also stored inside this management cluster. It's a very, very tiny cluster. Like it's distributed, et cetera, but it's a very tiny one compared to what we had in the past. So before we had that, as I have shown to you, and now it looks more like that. So that picture summarizes everything I was talking about before, and how a cattle architecture looks like, this cattle architecture looks like for us. So we are checking healthiness every 5 seconds. We are sending, based on the cluster status, less or more data with the goal of making all the clusters balanced and healthy all the time and transparent to the customer in terms of ingestion and search. And we don't trust on just 200 status anymore. The complete separation of the management cluster and all the other clusters. And as you can see, you have group 1 there. And inside group 1, we have a cluster of Elastic with 200 nodes, another cluster with up to 200 nodes. You don't have 200, you have 100 and something nowadays. And you have the group 2, group 3, a bunch of other groups there. And we can just decide to route specific profiles to different groups. And we can, right now, we can scale forever inside these groups. The only bottleneck nowadays is the aggregator on the management cluster, the client aggregator, which we will start to push Elastic on how to circumvent this limitation. But we are very far for the next 10 years on getting close to this client aggregation. And that's the impact in practice. It was with a lower cost, by the way. We did the migration to this new cluster. This SLO query performance is a query that we emit every 1 minute. This is for the last 1 year, this graph. I couldn't put the timeline below, but like you can see that after the migration, we were adjusting the cluster. We are still up a little bit, but after we did some, we identified some bottlenecks on I/O, and after solving these bottlenecks, we called that cattle rate 0, because instead of putting like 4 disks, look how this change of mindset brings a lot of benefits for us. Like, instead of putting 4 disks in every EKS Kubernetes pod, which is quite complicated, like things that were simple in data center, but like now in Kubernetes, like to configure for AWS disk makes your life miserable. We decided like, oh, I don't need that. I can just create more pods. And instead of paying for 2 terabytes disk, I paid for 500 giga disk, and I split in 4 Elastic nodes. So we start to call that a cattle rate 0. And also with replicas and completely distributed. And at the end of the day, I started to pay less. And I paid the same, but after doing some bin packing with these pods, we start to pay even less. And we had 4x better performance. And that's for indexing time. Like, one very important metric for us is the lag. Like, the time I take to index stuff is critical. And for like paying less after this migration and adjusting the cluster, we started to index like close to 4x as well with better performance. And here is what we like. Every time you see like this is the amount of message we we have on the Kafka waiting to be consumed. And that's a problem because if I take 1 hour to ingest the average is 2 minutes, we have very low SLOs, but if I take 1 hour to ingest, it's not important anymore, this log. The support doesn't want that. They want the log immediately when the log is pushed by my tenants. So after the migration, you see the lag just dropped completely. We had some events, but it was by our mistake in some deployment or something like that. After that, and the page just start to go down, like the number of pages we were getting because of ingestion. And this is in terms of savings, like our biggest cluster with more than close to 1,000 nodes, very big nodes, went from 761 to 633, like 17% in our biggest cluster. And we got a smaller cluster with 57% of savings there. And after all of that, while we were doing this migration, sometimes we had like pages and issues and customers saying, hey, the system is slow, it's not returning what I want, et cetera, et cetera. And we were always blind because the only thing that Elastic and OpenSearch will provide you is like a log saying it's a slow log or a security log saying, hey, in your specific node, in specific shard, saying, hey, this is the slow query, but the slow log will not tell you the user. And the security log will tell you the user, but not tell you the query. We were lucky that they have something called opaque ID that matches between both. And we were like, we need to do something about it because our cluster now is too big. It's a cattle. And I want to know when my things are bad and how to reply my customer because customer knew, I don't know if they knew, but it looks like they knew that we didn't have something to tell that the problem is not in our side, but in their query. They need to improve their query. And Elastic doesn't have a mechanism to say, hey, I'm going to throttle if your query is bad. There are a lot of Reddit discussions and Elastic forum discussions about that, and they will tell you, we don't know if the thread is bad until I run the thread in my cluster. I need to run the thread because the cluster is complex. We have a lot of knobs, a lot of parameters, like one cluster can be bad, for another cluster it cannot be. And we were like, okay, let's disbelieve that and let's try to do something about that. So what I did was to build this auditing service, which was quite simple. We just wrote some sidecar in our pods, which was collecting UDP. Like I was sending just all the slow logs and security logs to this pod. We did that in Python. It was just an UDP server listening at in some port. And we were aggregating that in Python and sending that to the management cluster. So the data cluster was blind, just getting these logs in management cluster. And we aggregate that in one row for every, we are distributing that to thousands of pods, and we are aggregating that in management cluster in one row. So I know everything in an aggregated mode about this query. And if my customer is coming to us saying, hey, my query is bad, the cluster is bad, I can look my dashboard and say, no, that's your query. 100% now. So, and also this service, of course, it started a surge of changing to Kato approach. You start to get a surge of toolings and people coming and saying, hey, now I know how your system works. It's stupid simple. Now I can just implement this new tool, this new auditing system, this new health check thing, like a bunch of other tooling, for example, the CI/CD pipeline. Now we are building a CI/CD pipeline that's super simplified and can globally deploy and roll back and roll forward stuff without human intervention, which before was not possible completely. And we right now can also think about rate limit top offenders and overcome this limitation of, oh, you can't know your query before you run that. The idea we are having is to create a separated cluster, mirroring the traffic on the load balancer and running these queries, these bad queries in this mirrored cluster. And we've been able to identify what are the profile of these bad queries and being able to block them to don't impact the other customers. So, and this is the face of the auditing service. Anyone can implement that. Like it was 1-2 weeks to implement in Python this UDP server. And it's doing really, really well for us to identify problems. And this is what the dashboard looks like. Right now, we know in this very big cluster of clusters and groups of stuff, we know exactly what are the amount of queries that my customer runs, the ratio between queries and ingestion. Because just getting Elastic statistics will not tell you that. It's very granular and not get disaggregate like the customer view. Also, we can identify that, like, for example, 16% of my queries can be cacheable, and we are thinking about not letting it to go to all my Elastic clusters, but like on the load balancer, put in a main cache or a Redis or something like that, and just return from there in milliseconds. Identify subqueries going to the cluster, like what's the time taken over time. If customer complain that they got a spike during that time, we know exactly how. You see at the end of the graph, yeah. Cluster was bad there. I had a lot of queries. And we know exactly which customer were running which query, which time, what was the node that were replying with on the max took time there. The max mean average, like all the statistics are there, aggregated for everything that is running behind the scenes on the cluster. And you know which tiers are being the problematic ones. Also, unique queries per user. If one user is causing problems, you know that. And yeah. And most importantly, this one, when customers complain, I just see this query time distribution. Like, oh, yeah, it's just you. 99% of my queries are OK. And I see your query here. It's just you complaining. Yeah, on the data cluster side, we try to make them, instead of different hardware profile, different configurations, all of them needs to be the same configuration, the same disk profile, CPU, memory, JVM. Yeah, and being agnostic to the data coming, it's just like if you have a bunch of clusters, the data by my load balancer decide where to put, so they don't know even which data they are storing. In terms of topology as well, index and chars, everything very uniformed. And customer doesn't have direct access anymore to my underlying system. And nothing beyond data run on this cluster. Like, remember, keep it stupid simple. And yeah, we start to route to groups, this group of clusters, so these clusters of clusters. Okay, yeah, the namespace. Yeah, also we made the namespace in Kubernetes to match exactly where we are routing to. It was a long discussion with the team about names to get to that, but it's been helpful. Agnostic or standard naming conventions, I already mentioned that before. And we created this dedicated namespace for this management cluster. And look nowadays how the whole configuration for the cluster looks like. And everything else is picking the configuration from there. Just that. It's a template, a Helm chart template. And like my load balancer is just looking at that and doing all the magic based on that. All the automation inside the load balancer configuration. And yeah, in the 1,000 feet view, this is more or less how this architecture looks like. And the outcomes. The architecture looks more like a MapReduce style. Maybe we think about hierarchical in the future, but we need to keep talking to Elastic guys if we can make like a cross-cluster search of cross-cluster search, like on cluster of cluster, because we are afraid of, after 10 years, reaching this limit of aggregating in one single place. Standard cluster size and configuration, it reduced a lot. Engineering ops, you jump in a cluster, you know what it should look like every time you jump in any pod, in any node. Internal names, better code maintenance, surge of automation tooling we are getting more recently. And it enabled more experimentation. As I was telling before, we are thinking about creating this mirroring traffic there and experimenting there. Everything that we see that looks good in this small cluster, that's a copy of all the others. And mirroring traffic, we can just apply to all the others. Think about that on economic terms. You can just change an instance type and check if that will have a good result and just spread that around. We couldn't do that before. And it's very convenient to upgrade any infrastructure because if you think about the routing mechanism, this health check mechanism, you can shut down anything, anytime, without any problem, without communicating customer. And for me, that's the biggest one. We reduced the build time and the migration time of the cluster from 14 weeks to 5 days. Last cluster, the biggest cluster we have, I migrated that cluster in 2 days. And before, it was like, no, I don't want to get this project to migrate this cluster. I need to talk to all the customers. I need to go to every single server. I need to route everything again. It brought problems. I need to stay after hours. No, like in 2 days, we are migrating everything. It's completely transparent to the customer. Up to 57% of reduction in computing cost. It was when we started to do the rate 0, cut-off rate 0, because it allowed us to do that. 4x better performance, and we could return that in cost. Like, we could make whatever trade-off you want. Like, oh, I have better performance. I will lower their hardware and give the same performance and better cost model. So it helped us to identify like bottlenecks, as I said, in I/O. And right now we are projecting from 50 to 82% of savings by moving from SSDs to 8Gs and doing more cut-off rate zeros, putting more and more cluster with smaller instance for the future. And yeah, let's acknowledge these heroes. That those are the people maintaining this thing and supporting me during the time that I was deploying that. And they are getting less page, so they are happy. Thank you. If you have any questions.